What secrets are hidden in the two distinct sub-Neptune populations? In the vastness of our galaxy, most stars host planets. Among these, sub-Neptunes, planets larger than Earth yet smaller than Neptune, are the most common. But a cosmic mystery has baffled scientists for years. Why do some sub-Neptunes appear dense, while others seem almost airy? An international team of scientists from the University of Geneva, Bern, and NCCR planets set out to uncover the truth. These worlds, ranging in size between 6,000 and 25,000 kilometers in radius, defy expectations. When their mass is measured using two different methods, something remarkable happens. One group appears much denser than the other. But why? The team of researchers asked the critical question, was this a trick of the instruments, or could there really be two distinct populations of sub-Neptunes? After rigorous analysis, the answer emerged. It's not an observational bias. It's a phenomenon rooted in the very formation of planetary systems. The key lies in planetary resonance. When planets orbit their star in perfect harmony, one completing two orbits while another completes one, they're in a state called resonance. Planets in this resonant dance tend to be less dense, while those that have escaped this cosmic choreography undergo collisions. These violent crashes increase their density, giving rise to a new class of heavier planets. This groundbreaking discovery not only reveals two distinct populations of sub-Neptunes, but also shows us that most planetary systems, including our own, were once shaped by catastrophic collisions. These violent events, like the one that formed Earth's moon, are written into the fabric of space. The rest of the news is in the link below. Do not forget to follow and share. Information multiplies as it is shared.